Okay. So this is my first presentation. I will try to make it brief. It's an introduction to HPC2N Kebnekaise and very briefly to HPC in general. And I am Birgitte Brydsö, as Pedro said earlier. I work as partially application expert, partially system administrator at HPC2N. So what is HPC2N? Well, it is short for High Performance Computing Center North, and it's a national center for scientific and parallel computing. And it's part of the Swedish National Infrastructure for Computing, which is called SNIC. And what does HPC2N provide? It provides state-of-the-art resources and expertise, scalable and parallel HPC, large-scale storage facilities. We have the project storage, Luster, which is where your space for your home directories and the storage we're going to use is. And it's also what is currently down, but it's going to work again, they promise me. Then there's Swistore and there's Tape. Those are both for more long-term storage. We do some grid and cloud computing with the WLCG, and that is the collider down in Switzerland that we are storing stuff for, and they're also running a lot of computations at our center. We have a small cloud, which is in production, but it is still only a very small one, so it's only used for people who have specific needs that cannot run on the regular system. And then, of course, we provide support. We have both the primary support, which is what you get to when you contact with support at hpc2n.umu.se with problems like why you cannot log in or something like that, or if you need something installed or whatever. We also have advanced support, which is if there's something that takes longer time and you need, for instance, an application expert assigned to help you with something. And we have dedicated support, which is usually where we help a research group for a somewhat longer time. And the application experts are Pedro and Åke and a person that's called Jerry. And there are some others who are partially doing application expert work as well. But I will get to that in a moment. And HPC2N is part of an international network for research and development. So HPC2N has 5 partners. There's the Luleå University of Technology. Luleå is, as you maybe know, located not so far away to the north. And then there's Mid-Sweden University, which is in the middle of Sweden, sort of, but it's located in Sundsvall. And then there's the Swedish Institute of Space Physics, which is in Kiruna. And there's the Swedish University of Agricultural Sciences, which has several locations, but there is a large location here in Umeå. And then there's Umeå University, which is where HPC2N is physically located also. As I said before, HPC2N is part of SNIC, and it's actually funded by Swedish Research Council, the Vetenskapsrådet, BR, SNIC, and various partners. And the partners is, among others, the ones I just mentioned. And HPC2N is part of several projects and collaborations. As you can see, Praise, IceGet, Essence, and several others. So HPC2N gives training and other services, as you are part of this training course right now. And there are research group meetings, which is where we meet with some of the research group and see if they need specific support. And we also go to the partner sites of the Umeå University sometimes to maybe make a short intro course or to help them more specifically with running their software. So this user training and education, that can be from half days up to 3 or maybe 4 days, and it's courses like this. We also have courses in various types of software and with GPUs, parallel programming, and other things that can be found on the HPC2N website under courses, where you can see which courses we are giving. And there's also a list of past courses, and the most recent year or two courses, you will be able to find the links to the material online, and in many cases, there will also be the recordings on YouTube. We run the introduction course twice a year, so that doesn't change that much between the years. It's only when there is minor changes that we update it. And that you can also find recorded on YouTube, and we are recording this one as well. So you can watch it again if you need to check on how to do something. And then HPC2N is also part of some national and university courses that we sometimes help out with. And we do various workshops and seminars. So the HPC2N personnel, we have our new director, which is Paolo Biantinesi. The previous one was Bo Kokström, who had been the director for many years, since the beginning of the HPC2N. Then we have a deputy director, which is Björn Torkelsson. And we have Lena Hellman, who is the administrator for HPC2N. And as I said, we have application experts. Jari and Pedro are officially application experts, but Åke Sandgren and Lars Wiklund and myself are also doing application expert work. And we have some other people who are also attached to HPC2N in greater or smaller degrees, but they also work on other things. And then there's the system and support group, which you can see the list of here. And these are the people that you may get in touch with when you write to support@hpc2n@umeå.se. So there's Erik Andersson, and there's myself, and there's Niklas Edmundsson, who is in charge of the tape storage. And there's Ingemar Fellman, who is working mainly with the clouds, and Magnus Johnson, Roger Oskarsson, which is mainly in charge of the grids. And then there's Åke Sandgren, who is also application expert. There's Matthias Wadenstein, who works with SNIC and the tier 1 for the VLCG. And then there is Lars Wiklund, also partially application expert. And the application expert have different areas that they are specialized on. So you can know which one it is you want to contact. You can contact one of them directly. You can, for instance, if you send the support mail, say that I have a problem in this area, I think I need help from an application expert. And then maybe say which one you need help from, or maybe also just say I need help, and then one will maybe be assigned. So I mean, it's not a big deal. And you get your contact just through regular support or the support form on the super page. If you have some specific problem, if your group has some specific problem, then we can help up to 100 hours, but usually it is shorter things. And the support is just like usage of the system in general is free for everyone that is part of Swedish academia or in a research group with someone in Swedish academia. HPC2N has users from many different scientific disciplines. There's bioscience and medicine, that is actually a large part, and there's chemistry, which is probably the largest part of the users. We have computing science, of course, engineering, material science, mathematics, statistics, physics, including space physics, especially from Kiruna. And then we have a growing group of people that work with deep learning and artificial intelligence. This is a somewhat old graph with some, just to see where do these medium users come from. And you can see there's a large chunk of them that come from Umeå University. And we also have very many users from KTH and from Uppsala. And for the large groups, it is more or less the same, except that here we also have people from Stockholm and Lund. So there are some large groups. But you can see there's actually not very many large project users from Umeå itself. So what type of software do people run? You can see here, GROMACS is by far the most popular, and that fits with, there's many users from molecular dynamics, many from chemistry, and VASP is also very popular. The chunk that's called unclassified is either small user installed pieces of software, or it's self-written code. So it's not specified. So let's look at the HPC2N's computers and resources. So we have Kebnekaise. That is the latest supercomputer that we have. We have had others before. We recently retired the Abbisco, which was our previous computer. It's named for a massif that contains some of Sweden's highest mountain peaks. It lies to the north, not very far from Kiruna. And it was delivered by Lenovo, and it was installed during the summer of 2016. And it was opened for general use on November 7, 2016. We also extended it in 2018 with more and newer nodes, some Skylake nodes and some Volta GPU nodes instead of just the K80 nodes. So we have 432 compute nodes of these Intel Xeon E5 2690V4, that is Broadwell nodes. And then we have Skylake nodes, those we have 52 of, those are the newer ones. And you can see there are 28 cores on each of the nodes. The Skylake nodes has slightly more memory and is also connected with faster InfiniBand. Then we have what we call the large memory nodes. Those are only 20 of. And that is for people who have applications that need quite a lot of memory. As you can see, there is 3 terabytes of memory on these nodes. And these nodes are actually considered a separate resource. So you don't get access to them if you just apply for a project at Kebnekaise. You need to say that I have this these applications that actually need large memory nodes, and then you can apply for use of this resource specifically. Then we also have KNL nodes, which are Intel Xeon Phi nodes, and as you may know, Intel discontinued this type of architecture. And it has been used by some people, but not very many. It is somewhat difficult to write good software for it, which also is probably one reason why it is being discontinued. But we have 36 of these nodes, each with 68 cores. It's a different kind of architecture, and some users like to run their code on it, and some have code that can run quite fast on it. So aside from these CPU nodes, we also have GPU nodes. We have mainly the K80 nodes from NVIDIA, and we have 32 nodes that each have 2 K80 GPU engines on them. And then we have 4 that has 4 on each one. These sit on Broadwell nodes. And then we have the newer ones. We only have 10 of those, the NVIDIA V100 nodes or the Volta nodes. Those sit on Skylake nodes, and as you can see, aside from CUDA cores, they also have tensor cores. So they are popular with people who run various deep learning and machine learning, but also with other people. So there can be quite some weight for those. So in numbers, Kebnekaise has 602 nodes in total in 15 racks. Takes up some space down in the machine room. And usually during normal times, we would take people on a trip to the machine rooms and see how it looks, but we cannot do that currently due to the coronavirus. In total, this gives 19,288 cores. Of those, the vast majority, 18,840 available to users. The rest are for managing the cluster. That is login nodes, servers, various nodes for the batch system, etc. And that is more than 136 terabytes of memory. We also have a lot of switches, of course. There's InfiniBand switches, access and management networks for Ethernet and such. And it's totally 728 teraflops peak performance, but the expansion was not included in this number. And the LinPack ran at 86% of the peak performance, which is reasonably okay. So we have 5 types of storage at HPC2N. There is the home directories, which is where your home space is located. So when you log into the system, this is where you get first. And this has 25 gigabyte. And you can put some things there, but not very much, obviously. So usually this would be things like maybe settings and configurations and a small number of installed codes and things. And this is, of course, backed up. Then there is the project storage, which is shared among your project members. And what happens is usually that someone applies for a project, and then they have some members of this project. And anyone who is a PhD student or above in Swedish academia can apply for it. Anyone in the world can be a member of the project as long as the PI, the leader of the project, is in Swedish academia. And this project storage is, as I said, shared among project members. So you would get a specific space to store it in, and you would create your own directory under it. And we will look at doing that later. This course project has a small amount of project storage to be shared among the users. So there's plenty for the exercises that we are going to run. Aside from this, there's also local scratch space. And this is only accessible per node. So when you have run your job on a node, then you will no longer be able to access what was there. So it needs to be copied before your job ends. And that can be done in a batch script. So that's not a problem. And it's usually done automatically if, unless you specifically ask to run it in this SNIC temp directory, in which case you need to copy it yourself in the batch script. Then there's also the SWISTOR storage, and that is part of the SNIC storage, which is nationally accessible storage. And it is something you need to apply for separately. And then we also have tape storage, which is for long-term storage and backup. And we do that for various of the departments at the university and also for some of the other universities in Sweden. So, as I said, to use Kebnekaise, you must be a member of a compute project. It has a certain number of core hours allocated per month. And if you're running on a regular CPU node, whether Broadwell or Skylake, it costs 1 core hour per hour. Other resources, for instance, the GPUs, will cost more. This is not a hard limit. A project can go over the allocation, but then you get lower priority. The only thing is you cannot, in one job, ask for more computation than you have hours in your project. But I mean, you can easily run 150% on your project with no problem. So it's not a hard limit, but your priority goes down the more you run in the project and the more the other project members run in it. And it slowly decays again, the usage, so that after, I think, about 50 days, then the usage does not affect it any longer. So then the priority up to a maximum again. And a compute project, you can have a default storage in it, and that is what we applied for this project. But if you want more, you also can apply for a storage project. And I will look more into this when we talk about using the systems in a little while. So what is high performance computing? Well, it in general refers to the practice of aggregating computing power in a way that delivers much higher performance than one could get out of a typical desktop computer or workstation in order to solve large problems in science, engineering, or business. This is a definition that can be found on the URL that is listed below on this page. So what do we mean by this? Aggregating computing power. Well, we have 620 nodes in the 15 racks, totaling 19,288 cores. That is compared to maybe 4 cores in an average modern laptop. So that is one reason to use the system instead. And you also would have higher performance. As you can see, there is quite a lot more arithmetical operations per second in our systems than there is in even a modern laptop. And they also have a large problems to solve here, because when is it large enough for HPC? Because there is, of course, some it takes a bit of extra time and effort to move stuff to another system and run it there compared to just run it quickly on your own laptop. So what matters is the problems you have big enough that you want to do that extra effort? And it usually is as soon as it's more than short jobs, because you don't want to sit there and wait while your own computer is bogged down by running codes for weeks on end. And there's also, of course, other reasons. There is we can have more memory, and we also have a number of software installed. You will have support and so on. What does it mean that a problem is large then? Well, it can be large in execution time. It can take a very long time to solve a problem. Or it can be large in the meaning that it needs a lot of memory, or it has a lot of storage use. And of course, if it takes a long time to run, you can fix that by adding more cores or more, for example, more CPU, more GPUs. And if you need more memory, you can have more memory per node. You can use the large memory nodes, or you can use more nodes and split it over it. So if it's just, if you don't have a lot of need for computation and not a lot of need for memory or storage, you would run it on a laptop. A little bit more you would run on high-end workstations, then on smaller computing clusters, and then on supercomputers. So it is mainly the larger problems that we target with the high-performance computing centers. So we also have various specialized hardware, of course. The GPUs we have are somewhat better than the ones you can buy usually as a regular customer. And we also have the Intel Xeon Phis, which while no longer being produced by the vendor, they can still do a lot of fast computations if you can get your code to run on them. And of course, we have high-end CPUs, and we have fast memory. We also have a license for quite a number of types of software, which you then would not need to get yourself. There's also some software which few people use, or which have very expensive licenses, and then in that case, the research groups need themselves to provide license for a piece of software. But the advantage is that we would have pre-configured the software for you, and it's ready to use, and we have usually also optimized it. And you can get support and documentation, of course. So there are two types of memory models for HPC that is relevant. You have shared memory, where everyone accesses the same data and that is easy to use. And then you have distributed memory, where you have multiple distinct memory spaces. Then you only has direct access to the local data, and then you need communication between the nodes, for instance, using MPI. And you can actually, the distributed memory would probably cases would probably be in many cases the ones you would run on supercomputers. But of course, you also have some amount more shared memory on our nodes, so you would also run that in some cases. But it would then run on inside one node. So what type of software would you run like that? If you just need one core, then you would run something like MATLAB, Python. You can run on that when you have single stream of operations. Of course, MATLAB has toolboxes, so you can run it on several nodes. And Python also has some MPI libraries and things like this. And of course, you can write your C and Fortran code, so it runs on many cores. You would then, if it's inside the same node, you would use maybe OpenMP. And you can use, if it's distributed memory, you would use something like MPI most likely. I will just go through this quickly because I can see we are a bit late. And then, of course, you will run on the GPUs. You can either write your own code in CUDA or OpenCL, or you can use things like OpenACC, or you can use the tasks in OpenMP and other things. I will just go through this, I think, because I think that what is the time? Just one moment. Yeah, I should be finished. So I think that this goes through most of the stuff that I had, and I will end this lecture now so that people can have maybe 15 minutes of coffee break before I go to talk about the actual usage of the Kebnekaise system. Does anyone have any questions about either the first lecture or the second one?
There is one question on the chat, Birgitte.
Just one moment, because
Or I can read it.
No, it's just that I had to exit the full screen thing. Does a project member also need to apply for project storage, or the principal investigator should apply for it, is the question. No, the project members does not need to apply for project storage. It's the principal investigator that does it. So the project members themselves don't need to know. Okay, in that case, I will stop now, and then we can take a 15-minute break, and then we will return to look at how to use the Kebnekaise system. And we will also before I start doing that, we will actually do a short test if people can get the thin link or any other software to connect to our systems up and running, and if they have their accounts working and things like this. So in 15 minutes, we will look at that and then do the lecture.